Well, good evening. I'm going to open Cut2D and show. Had a few questions from one of the owners, TruCut owners tonight. Another new owner, kind of like myself, trying to learn this as we go. Talking about just general things here that are pretty basic, things that we're all still learning. Parker, I'll show you what I was talking about with layers. Let's just open, well, I'll just show you how I'd bring these drawings in. So this is where I just put the size of the plate normally, and then make sure this is not turned on. I don't know what that purpose is, I don't use that. And then right here on this one it says import vectors, so I had already turned those to vectors. I saved those in my OneDrive. See if I can find out where that is. Let's see. Some drawings. So I converted some AutoCAD drawings they sent me to DXF files. So here's one I was telling you about. So it's just a 24-inch plate with some radiuses. These are half-inch radiuses and then a 1-inch hole in the middle. So first off, if you click on this, see, that's not a closed vector. That's what I was telling you. You got to make sure your vectors are closed, and this one's in probably each side is a vector and the radius is a different vector. So there's basically 8 plus the center, which is on another layer. Because if you look up here in the layers, I think it's these ones that are marked here. There's notes, and then there's layer 1 is the 2 layers that are up here. So anyway, just mark all of this to go ahead and close those. It's selected everything now. Now go over here to this little join open vectors and see it opens up. It says 1 closed and 7 open vectors. So all you do here is just push join. Now see, if you click it, it'll all come on that layer, and then this is on a different layer, so it's not connected to that, so it wouldn't matter anyway if it wasn't on a different layer. This is all closed, and this would be a 1 closed vector, so you just click on that. Now to put that into let's close that tool. A lot of times also when I get through with a drawing, and this is a real simple drawing, it's not that complicated, I usually do the vector validator. Click that, and if it has any issues with lines overlapping or not connected, over here it'll show these problems, and you can put search selected like that and make sure it's selected, and then it'll show it. If not, sometimes it'll say fix zero length spans and some of that. Anyway, you can look for problems that way too. Now if we wanted to cut this, or if you wanted to cut a whole sheet of these, for instance, first off, let's select all that and just kind of move it out here out of the way a minute. To nest that, which I've done, click that nest button, and then you set in your tool diameter, which would be like your kerf. That's always confusing because this is really set up for a milling or for a V-carve, a wood router type CNC machine. But you got your tool diameter is D right there. And you have your clearance, which is between that cut and the next tool path, I guess. That's always a little confusing to me. And your border gap, I guess, is what room you're leaving yourself around the parts, I guess. Rotate parts is either a 45 or a 90 according to Ross, so you can set that at 90 degrees or 45. It probably on a square would be best to have a 90 degrees, so go ahead and try to turn them in there goofy. And then put the number of copies. Well, we could probably fit 8 of those in here, but probably not that size. Let's just put 4 of them for this example. And then just apply. So see, now it shows there's 4. It's going to make 4 of those. And on that sheet, so then just push preview. And there's 4 of them. And because these are 24 inches, they won't fit with these numbers here on that. And actually on the ones I built, I made those 1/8 of an inch smaller, which was okay with the customer to go up to a 1/4 inch smaller. But so there's your 4. Now if you want to make a tool path on that, you can close this. No, you can't, can you? Okay, let's go back into there. I think you have to push OK. Now you can push right here to go switch to toolpath commands. And remember, there's 2 different layers here because you've got your center part and then this layer here. So just go to toolpath, outside contour. This is what we talked about, Parker. This is your outside cut, outside contour. Just like they're showing right there, and you always want to be going counterclockwise on an inside. Basically, you need to think about whichever way your plasma torch is moving, you want the cut to be on the right hand side of the cut. So that's going to be going counterclockwise if you're inside. If you're outside, you want to be going clockwise, which is called climb milling. If you were milling something, that's why this says direction climb. Always want that set on climb milling to get the best cut. Okay. And I think whatever you have set on, it'll stay that way the next time you're in here. So select our tool. And this is 7-gauge material, or 3/16 is what I'm using. And they're showing the 60 thousandths of an inch kerf, and I don't know, I think the book says it's 65. I haven't messed with that, and everything's been okay. Your feed rate actually is not this one, it's actually spindle speed, and it's on 100, so that's 100%. Just leave it like that, unless you're doing a hole. I usually turn them down to about 60 or 70, 60% probably, 50 or 60%, depending on the hole size. These are pretty good size holes. And don't push apply, because I think that messes your tool database up. Just push OK right there. Notice it's still only selecting the outside. Now let's go down the list and kind of ignore some of these things that have more to do with probably milling. And just go to leads. I don't know much about this ramp toolpath stuff. I really don't know. I don't worry about that. Add the leads. If you don't have a place to put a sharp corner, you probably just use your circular leads. Whatever amount it'll let you. The lead length is 1/4 of an inch on that one. I got a little bit of overcut on that. Probably don't need the overcut. I just, on this bigger plate, I thought I would leave that. You can name this. I usually name it outside. Do an outside cut on that one. And then just push calculate. Well, you can go here and look around. Start, optimize start point. Seems like it works good. I think it figures out where the best place to put your start points is on that. Corners, use sharp corners. I don't know. That matters on this. There's not really any sharp corners, but I don't even know why that's in here like that. But now select selector. Let's go in here and let's pick that layer 1. We already figured out the layers. The outside is layer 1, so that's okay. Now calculate. So there's our tool paths. You can see where the lead end is going to come in, make the cut. When it comes out, if it comes in here and make the cut, then it's going to lead out. That kind of pulls your dross and stuff out away from the material, so it's not trying to stick together. I believe that's the way I understand it. Okay, so then we can close that, and there's our tool path. If you hover over that, you can see it says it's that tool is 85 inches a minute, and what else does it say? It's at spindle of 100. That's really should be 100% feed rate, so it'll be at 85 inches a minute is what it's going to cut that at. That don't mean Mach 4 is going to cut it at that, because that's turned down. I usually turn that back up. On this simple cuts, you can run. You need to run them as fast as you can, because something else I've learned is if your torch height control will allow the torch to drag the material. If you're running slower than the speed, you need to run a higher torch voltage on your torch height control. Probably need to go about 5 volts higher if you're running a lot slower than what the Hypertherm book or the tool here shows that it's supposed to run. So I've learned that the hard way here lately too, so just kind of play with that. On this particular run, I've been running about 138 or 39 volts. I think the book showed about 130, so you just got to see how it runs for you. Make sure it's not touching the material. Alright, so now we got the outside contour done, and now we want to do the inside. So let's go back in here and do another operation. We use that same tool. We don't really need to mess with that. It's still set. This time let's go to inside contour. We're going to do the holes. Still set and applying. Everything's set just like it was. Leads. This time we can run a straight lead on a hole. On the rod, if you want to run a 90-degree angle is fine. That's going to come in from the side. It's going to lead in and cut. And he doesn't go half the distance of the hole, but these are big holes, and it seems like it's just out in midair. So I like to turn that. That's fine. About 1/4 of an inch is fine to get. And a little overcut. Seems to work fine for me. My holes are real clean on these parts I've been making. I'm going to name this one holes, and let's go select that layer, and that layer is actually called notes on this for some reason. So you see that it is selected. That's what it's selecting, is the holes, because we just picked that vector. And now let's calculate that, and let's see what it's going to do. See, it's just going to come in. Well, what's it going to do here? I guess it's going to come in and pierce. And it's going to come, and it's going to go counterclockwise. It's going to do a little bit of an overcut right there, and it's going to come away from it and come back there. So unless I'm forgetting something, I believe that's all there is on that one. Let's close that. Now, here's something else. It's going to do these in the order you've got them here. Well, you always want to do your inside first before the part gets loose in there. These parts are heavy, so they're not going to be loose anyway, but just as a general rule, always do your insides first. And so right here you can click this arrow and it traded places with those. Now you can look at those tool paths and it's not going to be right. We really want to create a merged tool path when you have 2 different layers like this. So I think somewhere you can look at your preview tool paths right here. So it's going to start. This thing's weird the way this mouse works on this particular screen. It looks like it's going to come in and cut all of the holes first. See, and that's kind of silly because you're just running the machine all over the whole sheet to do holes, and then it's going to have another operation that's going to come in and do these cuts. So let's not do that. I don't know how you get back out of this. Let's see. Now, what we're going to want to do is do a merged. Let's close that. See where that says create a merged toolpath? So, and you can name that anything you want. This particular part's called J1 that I'm making. Just say J1 test, something like that for this. So let's merge toolpath. See, now there they are, but you got to unclick your original toolpaths because now they're all in that one. See, now let's see if we can see what it's going to do. See, now it's going to go cut this hole. Then, man, I don't know what to do about that, but that it doesn't really let you. This thing's zoom. But anyway, it's going to cut the hole. Then it's going to come here, and it's going to cut this part, and then it's going to come back and cut this hole, and it's going to come cut that part. So instead of chasing all around doing the holes and nothing else, it's going to cut one part at a time. Is what it's going to do. So, and Ross has a video on this. It's pretty easy to understand. Once you do this a few times, the videos make a lot more sense that he's making. And I've just recently, probably in the last week or so, started my first nesting with this. It works pretty well, actually. I'm fairly pleased. I don't think there's quite as much control with this as there is with sheet cam, but sheet cam don't have auto nesting like this. You can put, well, I'll show you. Like I can bring in import vectors right here, and I could bring in some more parts like I've been making these parts too. And see, again, this is not closed vectors, so I always have to go in and close those vectors, join the vectors. Now I can nest that into here. I would have done that before I did the toolpath to make it work right, but I could still go in here and well, it's not wanting to let me do that since I've already got a toolpath, I guess. But anyway, that's what you could bring in as many parts as you want and fill this up with different kinds of parts automatically, and it'll put them wherever it feels like it can. So anyway, that's really all there was to that. I can go back into that toolpath. After you do all this, you just go here to save toolpath, and again you name this. You make sure you're selected the right ones. I can show you. If you unselect that, then there's nothing there. If you selected the outside, you only see outside. If you selected holes, you're only going to see out. Make sure you have this selected the way you want to do. That's the merged file that we made. That's going to do both layers. And so now we can save the toolpath. I don't really want to save this one. This is a test, but that's all you do is click that, name it, put it where you want it to be, and save it. And what I do, this is I'm inside in the office here, but I just save this in my OneDrive folder. That way I'm on the internet on both machines. So, and then when I get out to the machine out there, it needs to be in the G-code folder that's on your machine, your computer, on your plasma table. So when I go out there to the machine, machine, all I do is open the folder, your File Explorer folder here. Now, all I do is find that file this is where I put them right here, and I just drag this into the G-code folder that's on your desktop, on your plasma table, and drag it in there, and then just close everything, and then when you get ready to run, you open Mach 4, and then you just load your G-code file that you just moved into there. That works for me. I mean, some guys probably put on a little thumb drive or whatever. It doesn't matter as long as you get that file and go get it and load it in Mach 4. So anyway, that's all I can think of at the moment. I was talking to Parker this evening, and he had some questions. He's about 2 or 3 months into his about it like I am. He's trying to learn some of these tricks, and the more parts and more things you do, the more stuff you end up learning about how to do certain things. And I mean, I've asked Ross and different guys on questions about this occasionally if I run into something, or I just sit down and watch another video that Ross or somebody has made, or just search. There's plenty of places to search online, YouTube or somewhere where people are using this for V-carve, and the drawing and using this stuff is pretty much the same, even though it's V-carve, and you can tell the differences when you don't need to pay attention to if they're milling or something, but setting up vectors and different things like that is the same pretty much. So anyway, that's all I've got for now, and I just didn't know that some people that maybe were a little more inexperienced than I am, which is kind of amazing to me because I don't feel real confident with this yet either. So anyway, I'll probably come up with another video soon to show some of this work that I've been doing out in the shop. I've already recorded quite a bit of footage I just haven't put together yet. So anyway, appreciate you watching this little quick video, and we'll check you next time. Goodbye.